by cirrus that's moving out of the top of these intense hot towers, is what we call them, these thunderstorms that are most persistent west and northwest of the center. But so the cirrus, the outflow from those thunderstorms, has covered up the eye once again this evening after it was a lot clearer earlier in the day. The reason for this is most likely some easterly wind shear. So we see we had a little bit of wind shear that's been basically impacting the system from the east ever since it formed in the Caribbean. That's keeping most of the thunderstorm activity weighted off to the west of the center. And you can't get a really well-defined eye when you have such a lopsided storm like this, or at least it's very hard to. So when the storm was a little bit more symmetric earlier today, you were able to get that circulation strong enough to cause all the sinking motion in the eye. That sinking motion was then strong enough to evaporate these or sublimate these cirrus clouds. That's no longer the case right now, though I don't think that this is a noteworthy development for the storm's intensity. It certainly looks a little bit less healthy than it did a few hours ago, right? That looks like a lot healthier of a storm than this does, but I don't think that this really changes the forecast thinking for parts of Louisiana, where the storm is expected to make landfall in roughly 24 hours, maybe a little bit less than that. So tonight I'll be watching to see basically, can the eye reemerge? Can some of these thunderstorms wrap into the up shear half of the storm, right? That's been the big question. Is we had all this thunderstorm activity in the storm's northwestern quadrant. That's where it's really getting going. And then to what extent can those thunderstorms pivot cyclonically around the eye and sort of set up as defense over here on the eastern side of the storm to fend off that shear from the east. Over the course of the next 12 hours or so, the shear will actually shift towards the southwest. So we'll see the storm be sort of lopsided in the other direction, with most of the thunderstorm activity off to the northeast. But I'll talk about that more in a couple minutes. So the hurricane hunters have been in Delta investigating this evening. Here's a look at some of the data they've been collecting. Of course, plenty of strong winds that they're finding, but nothing really earth-shattering, and a bit weaker than what we saw in the flight from a few hours ago. So it looks like most of these wind barbs up here in the northern eye wall, remember that's one of the stronger portions of the storm. That's right around 105 knots right there that I can see in that wind barb. The flight earlier today had 120 knots. So still some fluctuations with the intensity, perhaps weakened a slight bit due to that shear that we talked about earlier. But really, this is a storm remaining more or less in steady state this evening. So not a whole lot to report there. We can take a look at some of these cross or time series, but they sort of function like cross section plots, and you can see that the northern side has a whole lot more oomph than the southern side. That's basically going to be the defining feature of this storm as it makes landfall. The northern or the front side of the storm is going to be a whole lot more intense than the back side of the storm, and that's again due to that wind shear. So that's a quick rundown of the recon observations. We can take a quick look at the dropson that they dropped in the eye. The important thing to note here, or at least the interesting thing to note, is this. Basically, it's this right here. So this is what we call a subsidence inversion. It basically is a signal to those of us forecasters that there's sinking air in the eye. Now, why would this? So this is the dew point line. The green line is the dew point. The red line is the temperature. Why would this sort of separation of the dew point and the temperature, where the dew point drops quickly right above 800 hectopascals or 800 millibars, that's like 4,000 feet above the surface, and then the temperature increases in that spot. So basically what happens here is, imagine you're a little air parcel, you're descending, right? You're descending from a lower pressure to a higher pressure. That means that your volume is going to sort of shrink. That compression is warming the temperature. It's putting energy into this parcel. So that means that as these parcels are sinking, they're getting warmer, and as they're getting warmer, they're getting drier. And that's basically what we're seeing here. Because you're making the air warmer, but you're not adding any moisture to it. So when we see this divergence of the temperature and dew point lines in the eye of a hurricane, that's a signal to you that there's sinking motion. Sinking motion in the middle of the eye is a sign of a stronger storm. You don't want sinking motion in the eye wall. That's where you want all the rising motion. But to have sinking motion in the eye wall is a sign of a robust circulation. So just a little tidbit to note there. Central pressure, or the surface pressure on the dropsonde was 956 with 10 knot winds, so that's about a 955 millibar central pressure. That's up a smidge from the earlier recon missions from a couple hours ago, but really nothing that noteworthy. Speaking of other interesting recon obs, this is a tweet from Tomer Berg, PhD student down at OU, which is a really cool plot. He's a coding master here, and he has figured out how to do these. This is a plot with a radius. So the storm radius is on the x-axis here. This is right at the center of delta, and then this is getting farther away from the center of delta as you move off to the right. Then this is time on the y-axis. So this is when the storm was first rapidly intensifying a couple days ago, and then you move all the way up, and here we are this afternoon at the top here. And then what you're seeing plotted is wind speed at flight level. So many interesting things to talk about here. I mean, we could go on and on, but the couple of key ideas are that you start out the initial phase here. So we're tracing out the radius of maximum winds. That's basically what we're interested in. Now notice that. So I'm just going to follow with my mouse here to sort of the highest wind values, right? And notice that as I go along in time, the radius of maximum winds is getting closer to the center, so it's shrinking. And when the storm was at its peak intensity, what was this, like Wednesday afternoon, Tuesday afternoon, the radius of maximum winds was very, very small. It was like 10 kilometers, right? 12 kilometers, something around there. That's tiny. Then the storm weakened due to shear. The radius of maximum wind expanded again. Then it made landfall in the Yucatan, and the wind intensity dropped off here. You can see we never got those category 4 winds back. Then there's this sort of period of disorganization as the storm tried to rebuild and recover its inner core. Now we have a new inner core. It's considerably larger. The radius of maximum winds, instead of being down near 12 kilometers, it's out here near 30 or 40 kilometers. So we have a much larger storm. And then we've started to see a subtle contraction moving into the afternoon here. But the real thing to note is that now, hurricane force flight level winds, right? That would be an easy sort of parameter to trace out here. So here's the hurricane force flight level winds. And then I'll trace out the tropical storm force flight level winds in a slightly different color. And this will give us a lot of insight into how the storm's changing and what the implications of that are for the Louisiana coastline. So if I'm looking at the contour interval correctly here, something like this. So this is tropical storm force. This is hurricane force. All right, I know it's a little bit messy at this point, but the key idea I want to highlight here is that right now the hurricane force winds extend farther from the center than the tropical storm force winds did a couple days ago, right? You can see here at 75 kilometers away from the center right now, we have hurricane force flight level winds a little bit lower at the surface. Back on Tuesday, Wednesday, we had less than tropical storm force winds at the surface here, or at flight level, so less than that at the surface. This is very important for folks in Louisiana, because what this means is that a wider swath of the coastline is going to see strong winds, hurricane force, tropical storm force, whatever threshold you pick, a wider area is going to be impacted by those winds. And because the circulation is so much larger now, a much larger swath of the Gulf of Mexico is being subject to strong winds. What does that mean? The storm surge is a lot stronger now. It's going to be a lot higher than it was in the Yucatan, because you get a big storm, that's going to be moving a whole lot more water than a small storm, even if the maximum winds in the smaller storm are more intense. So storm surge, really the biggest threat to be worried about here as Delta comes on shore. This is regardless of what happens with the intensity over the next 12 hours. If this thing, totally, I wouldn't say totally fall apart, because storms don't just totally fall apart once they've assembled this much momentum. But if we were to see a period of sharp weakening down to a Category 1 storm, that does not change the surge threat. So that's something to keep in mind. So speaking of interesting operational data, this is a radar image, a series of radar images of the outer bands or some lead disturbance. It's not immediately clear to me. I'd have to go zoom out on satellite imagery to see if this is actually an outer band associated with Delta, or if it's just something along a little upper level disturbance. But this radar imagery from near Lake Charles, Louisiana, is being brought to you by a mobile Doppler radar truck that is part of a series of groups associated with the University of Oklahoma. They have parked their truck here just east of Lake Charles to provide radar coverage as Delta moves onshore, because you'll probably remember the Lake Charles radar station. They do have one. It was destroyed during Hurricane Laura. They haven't finished rebuilding it yet. So now this mobile Doppler radar truck will be giving us valuable insights into Delta's structure as it moves onshore. There are other radar sites. I think there's one over near Houston and one over near Baton Rouge. So these will be your options to get radar data as the storm moves onshore. All right, so we've talked so much about what the storm's doing now, and that's mostly, in light of, normally I'd focus more on what the storm was going to do, what the forecast would be. But now that we're 24 hours or less out from landfall, there's not a whole lot more forecasting to be done, right? We've done most of that work in the past few days, and now we just sort of watch it come in. This is where I pass the baton off to Mark, who really specializes in all the on-the-ground data collection and the live cams and the pressure sensors and all the spectacular work that he and the rest of the team is doing down there on the ground. So my job is sort of beginning to draw to a close here, because I don't have all that much more to say about the forecast other than what I've already said in the past few days. But with that in mind, we'll just take a quick look at the forecast here, and then I'll let Mark get back to it. So this is an ensemble plot. This is basically showing you a composite of all the European ensemble members, all the all the UK Met Office ensemble members, and then all the ensemble members run by the NOAA GEFS. Basically, what we're looking at here is a track confidence index. That's how you could / should think of it. So red value, high confidence index. That means we really know where this thing is going. Once we get down to the cooler colors, we start to have less confidence. And this is basically like confidence that the storm is going to be within 200 kilometers. That's the rigorous definition. So we're very confident that it's going to be within 200 kilometers of where it is right now, because of course it's already there, right? So this is why we have this perfect circle right now. As we move out in time, of course, there's going to be more uncertainty about what the storm's doing. So we're going to see that confidence index drop a little bit. But you see, it doesn't really drop a lot, right? So we still have extremely high confidence that the storm is going to be, within 200 kilometers, or, like within this zone, and, even less than that, right? You can see all the ensemble members have the storm within this much narrower quarter right here. So you notice that, Tomer has drawn a nice ellipse for us here. That's this blue thing. You notice that the ellipse, ellipses have major axes and minor axes, or a major axis and a minor axis. The major axis being the longer axis, the minor axis being the shorter axis. So what this tells us a whole lot about how to think about forecast uncertainty in the coming days. I say in the coming days, we only have to really think about this for another 24 hours, which isn't that great news. So here's our track, right? Our general track is that the storm's going to it's moving northwest right now. It's turning off to the north. Then it's going to be moving off to the northeast. So that's like our forecast track, or maybe it goes something like that. I don't really know. But anyways, our forecast track is as the storm is approaching landfall, it's going to be moving from southwest to northeast. Now, if we go back to our major axis of this ellipse is also oriented northeast to southwest. And that is roughly parallel to the direction of motion. So when we have our ellipse that's when we have the major axis of this uncertainty or ensemble ellipse that's oriented roughly parallel to the storm's forward motion vector, that indicates what we call a long track spread. So what do we mean by that? Well, it means that we know where the storm's going with very high confidence, but it just means we don't quite know how fast it's going to get there. So we can explain this a little bit better by moving forward here, right? You notice that all of these lines are extremely tightly clustered, right? Once we move all the the sort of mess of the other stuff that's being displayed on the plot, which is obviously super valuable, but it gets a little cluttered. Oh, my screen seems to have gone dark here. I don't know what's up with that. Technical difficulties. Mike, can you hear me? Can you still see the screen? Oh, this is so weird. Everything on my screen just totally blanked. I have no idea what happened. Well, I apologize for that, folks. I was gonna keep explaining a long track and cross track spread, but I guess you just have to look at my face for the next couple of seconds, and then I'll see about figuring this out. Anyways, the upshot of all that is that we have a really good idea of where the storm's going. It's going to Cameron Parish, Louisiana, plus or minus 5 or 10 miles. We have a little bit less confidence about how fast it's going to get there. But the basic idea is that it's going to be making landfall sometime in the latter half of the day tomorrow. So given our little technical situation here, that's it for me for now. I'll be back perhaps tomorrow morning with another update like this. In the meantime, stay safe, especially if you're in the path of Hurricane Delta, and have a good evening.